Yeah.
Thank you. Good. So we start with 12.7. Let's look at few equations and simplifications and so on and so forth. Let's start with problem 48 on page 762, in which we have natural log 3x equals 0.76. We're asked to solve for x. I'm getting my calculator here ready. Good. So, what did we say about a log function? If you remember, let me just refresh your memory. An exponential function, remember how it looks like, right? It's either this or this. So what is defined on? What is its domain? The domain of an exponential function.
Wouldn't it be negative infinity?
Of course, all real numbers, indeed. Since we know the graph, so this is domain. Can anyone give us the range? Just remember the graph and you will know the range.
0 to infinity.
Excellent. What is the inverse function of the exponential function? How do we call it? What is its name? That's why they are both in the same chapter. So what will be the inverse of the exponential function?
Log.
Excellent. Since it's the inverse of the exponential, what will be its domain?
0 to infinity.
Wonderful. Since it's the inverse, so this is range. And what will be its range?
Negative infinity.
Right, because it's the inverse function. Absolutely. So then when I apply log to this quantity must be greater than 0. So first I have to state its restriction, 3x greater than 0, divide both sides by 3. So if the answer or the solution of this equation is not a number greater than 0, I will say no solutions. How do I solve a logarithmic equation? What is the idea behind this? What do I have to do?
Get x to one side on the other side. Or get
I
x
cannot break log from 3x. But I know the most important concept in this chapter. What was the most important concept in this chapter?
to find the inverse.
No. That is important too.
Oh.
Ah,
Can replace it with the log function.
with an exponential equation. So any log equation can be replaced by or substituted with a log equation, an exponential equation. Can anyone give us the log? The exponential equation for this.
Should be log.
I cannot change a log into a log. I have to-
Natural.
I have to change this logarithmic equation into an exponential equation. So log cannot appear here. How do I change it?
Would it be
Yes?
to the
Yes.
power of 0.76
Wonderful.
equals 3x?
Excellent. Perfect. Good. So then from here, I know how to get x. How much is x?
8.76 over 3.
Careful.
Oh, 8.
Right.
All right.
E to 0.76 divided by 3. Very good. My calculator. I put it in. And y equals. I'm sorry, I don't need to because I'm not evaluating. So the numerator is E. Right here where a natural log is. E to power, I like to put parentheses. So 0.76. 0.76. Close the parenthesis and come down. Remember you have to, this is software problem, divided by 3. Good. So I get 0.7128.
Which is greater than 0.
Good. 0.7128 is greater than 0 is acceptable. I want to make sure that this is true. How do I check this? I have some doubts about my work. I just want to make sure that I'm not losing. So I want to check. How do I check this? Yes?
Substitute that for x.
Where? Exactly? Yes?
Into the original.
Right. How do I, so just dictate and I will punch it in.
It would be just the natural log
Excellent.
3 times
The previous
Yes.
answer,
previous, yeah.
right here, because I want a whole thing. I don't want to truncate it. And when I hit enter, what should I get?
Should get 0.76.
Right. Otherwise, X is wrong. It's incorrect. And that's it. Good. Any questions on this problem? Okay. Here's another one, 45. Log 3x minus 2 equals negative 0.8. 1 minute. Okay, 2 minutes. I want to see the restriction first.
You gotta change it.
Oh. I was so excited. And nobody could even see my excitement. I want to see the restriction. In other words, find the domain, and then I would like you to solve it. Is there a traffic problem outside?
There's always traffic.
Yeah, it was horrible.
Especially for 100.
So I should wait with my attendance?
Maybe.
If they show up, I'll change it. Can anyone give us the beginning of the restriction? What will you write in order to solve, to get the domain?
X
No, log is not applied to x. Log is applied to,
is 10.
log is applied to, let's look. What is log applied to? Here, natural log was applied to 3x.
So now it's
What is
3x
log
minus 2.
applied to here?
It's the equation 3x minus 2.
The expression 3x minus 2. Therefore, 3x minus 2 must be
Greater than 0.
excellent. That's the restriction I have to state. The quantity that log is applied to, which in this case is 3x minus 2, has to be greater than 0. I move 2, divide by 3. If the solution is not greater than 2/3, I will say no solutions. Good. What is the next step?
Make an exponential,
Yes, please.
which
Ready? Yes?
Would it be 10 to the negative 20?
Excellent. Equals?
3x.
Very good. What do I do next? So solve it. Take 1 minute and solve this, please, and give me x. So what will be the first step here? You will
Add 2.
and divide by?
3.
Very good. So this is 10 raised to negative 0.8. We add 2 and we divide everything by 3. And what is the approximation for x? I need a calculator and I will punch it in. Don't forget parentheses for the top. Around the top you have to have parentheses. Then we have 10
0.9439.
caret in parentheses negative 0.8. Close the parenthesis, you have to come down, and plus 2, close the parenthesis, and divide by what? Am I dividing by 3? I got 0.7195, is that correct? We can check in a minute. We'll see in a minute if it's true or not. How do I check?
You plug it back in.
So in log, parentheses, 3 multiplied by the previous answer, subtract 2, close the parenthesis. When I hit enter, what should I get? Right. If I don't get negative 0.8, something is wrong. I get negative 0.8, therefore 0.7195 is correct. Now, is this, I should have asked that first, is this bigger than 2/3?
Yes.
Yes, because 2/3 is 0.6666666666666, and this is 0.7. Good. Okay, let's evaluate number 50. In number 50, we have log base 3 of 2. We're asked to evaluate this. I have no idea what number I raised to 3 to get 2. I can do this by hand. But I have a change of base formula. Which base would you like to use? In the calculator, we normally have 2. Some calculators allow you to put in the base you want, 3, 5, 15, 2500. But most of them don't. So, at least not now, or at least not the ones that I know and I work with. So, what is the change of base formula? First of all, which log you would like to use? Normally we have log, which is base 10, or natural log, which is base e. Which one would you like to use? It doesn't matter. There is only one number I raised 3 to get 2. There is only one. I can't get 2 different numbers. So, which one would you like to use? This or this?
Natural log.
Good. So then it's natural log of 2 over natural log of 3. If you had said log, I would have written log 2 over log 3. Both are the same. Obviously, there is only one number. So then, I have natural log 2, don't forget parentheses, close, divided by natural log 3, close parentheses, okay, and I press enter. And I get the answer, 0.6309. So this is approximately 0.6309. Okay, how do I check my work?
Plug it back into the original.
I can't, so how do I check this?
You just use log.
Careful. 3 raised to this number should give
Oh.
us
Should give us 3 over 2. 3,
3 raised to this number should give us,
3 raised to 2.
okay, let me show it. So I claim the log base 3 of 2 equals, it's approximately 0.6309. How do I check this? I want to check.
You can be able to move it to the other side. It should be 3 to the power of 0.6.
Exactly. Must equal.
That must equal 2.
Very good. So let's check. So I have 3. Caret or power. Previous answer. When I hit enter, I should get
2.
2. Let's enter. 2. Is that okay? Good. Moving on. Okay, so we can now go backwards to section 12.5, in which we are asked to solve some equations and change an exponential equation into a log or a log into an exponential. So problem 10 on page 749. Log 1, I'm sorry, it's natural log. Natural log of 1 over e equals -1. They want us to change this into an exponential equation. Can anyone dictate?
Swap the camera.
Natural log of 1 over e equals -1.
E -1 equals what?
Equals?
1 over e?
Is this true? Is e to -1 the same with 1 over e? Correct. Good. Now we would like to look at problem 26, in which we are given 3 raised to -4 equals 1 over 81. Now we're asked to go backwards. We're asked to determine the logarithmic equation.
Is it 81 to -4?
So first of all, I have to write log. I know that it has to have a base. I know it's out of a whatever, and I know the answer must be whatever. All these are not the same, okay? So we start with the base. What is the base?
Base should be 3.
What do we raise it to?
-4.
What do we get?
1 over e.
Let's check. 3 raised to -4 equals 1 over 81. Is this okay? Yes?
Yeah.
Okay. Now we want to look at 32. And 32, I just lost it. Okay, I got it. Log base 2 of 1 over 32. They're asking us to find this number. And we want to convert it into an exponential equation. How do we do that?
Wouldn't it be base 2?
Yes? Raised to
Y.
whatever, or y. If you want to put y, let's put y, that's fine. Equals?
1 over 32.
Very good. Now the question is, can I present both with the same base? Because if I can, then I can easily solve this. Yes? 2 to which power?
6.
But that would be 64.
No,
And not 1 over 32.
1 over 6.
So it's what?
1 over 6?
-5 indeed. 2 to -5 is 1 over 2 to the 5th, which is 1 over 32. Remember, we are not simplifying the base. I don't want to see that. This is the idea behind solving this equation. Two numbers are the same, and they have the same base. What has to happen to their exponents?
Definitely the same.
Right, so then y equals -5. Therefore, this number is -5. Okay, a couple of equations now. Let's look at 58. Log base 2 of 16 equals x. Let's look at 62. Log base x of 27 is 3. And 55, and then we can move on. Log base 8 of x is 1/3. We're asked to solve these equations. Can anyone help with 58?
It's 2 of them.
Can I present both sides with the same base?
Yes.
So then 2 to the x equals 2 to the,
Third.
careful, that's 8, fourth. So now again, two numbers are equal, and they have the same base. How much is x? Good. Are we working on 62? Okay, so let's work on 62. Can anyone tell us what to do with 62?
Next to the 30.
One thing we have to mention. Since it's the base, what are the conditions for the base? For exponential as well as log. What can the base be? Definitely not
Not
0.
or 1.
Not 1 and not
A negative.
excellent. Great. So then x has to be either greater than 1 or between 0 and 1. Excellent. Well done. Good. So we got new blood. Savannah showed up and she's helping.
Next to the 30 is 25.
So x to the third equals 27.
Third
What?
to the third.
Very good.
X equals 3.
Is it a number greater than 1 or between 0 and 1?
Yes.
Acceptable. Excellent. We're working on 55. What is the restriction now? That's not the base. That's the number that or expression that we apply log to.
Cannot be 0.
Greater than. X must be greater than 0. Remember from the beginning? This condition right here. This expression must be greater than 0. Okay, so are we working on it or can we convert it?
Isn't it 8 to the 1/3?
Very good. Now we know something about 8 to 1/3. anything that has power that is a fraction. What does this mean, really?
X is negative.
Careful.
It's 2 to the third.
Not the square root, cube root. Very good, excellent. So the cube root of 8 equals x, and x is 2. Is this a number greater than 0? Yes, acceptable. Okay, we're going back now to section 12.3, in which we will look at a word problem, and we will look at some more equations, but this time, can anyone tell me what equation is this? What type? Let me write it. Let's say 36 on page 736, and the equation is 4 raised to 3x minus 7 equals 32 raised to 2x. Can anyone tell us what type of equation is this?
Exponential.
Of course, because the variable is at the exponent level. Excellent. 2 minutes. Can anyone give us the first step?
Convert it into
Good, I'm ready.
it turns into 2 to the power of 2 times the work to the power of
Very good. Equals?
minus 7 equals 2 to the power of 5
Excellent.
raised to 2x.
Perfect. So that's the first step. Very good. So I copy the base. What happens to the exponents?
They multiply.
Excellent. And what would be the new power?
6x minus 14.
Very good. Do we all agree with 6x minus 14?
And then that goes into 2x.
Very good. Again, the concept is this. Two numbers are equal and they have the same base. What has to happen to their exponents?
They have to equal the same.
So 6x minus 14 has to equal 10x. What type of equation is this?
Negative.
Excellent. So I have to separate the terms. If it were quadratic, I would have had to set it equal to 0. Different story, but it's linear. So let's say I subtract 6x, negative 14 equals 4x. So therefore x equals
4 over 14
negative
over.
14 over 4, which is negative 7 halves. Notice that we did not state any restrictions. There are no restrictions on exponentials. Exponentials are defined everywhere. There are restrictions on logarithmic ones. Good. Do we need more, or can we look at a word problem?
Can you have one more, please?
Yes. Let's say 35, 81, 2x minus 1 equals 27 raised to 2x. Can anyone give us the first step, or should we wait?
Convert it to 3 to the 4th to the power of x minus 1 equals 3 to the 3rd to the power of 2x.
Good.
And then you get 3 to the 4x minus 1, or minus 4 equals 3 to 6x.
Two numbers are equal and they have the same base. What has to happen? The exponents must be the same. So 4x minus 4 equals 6x.
You get negative 2x equals 4, and then negative 2 equals x.
No restrictions. They're exponential. Good, let's look at a word problem. 39. On page 736. Okay. Cheese production in the United States is currently growing at a 3% rate per year. The equation y equals 8.6 multiplied by 1.03 raised to the x models the cheese production in the United States from 2003 to 2009. In this equation, y is the amount of cheese produced. Y, amount produced, and in billions of pounds. X represents a number of years after 2003. So x equals what represents 2003? How much is x equals? Okay, let me read that again. X represents a number of years after 2003. So what will you say x equals for 2003?
3.
Excellent. Good. First question. Estimate the total cheese production in the United States in 2007. And second question, same thing in 2015. Assuming in 2015 is outside of the range. So assuming that the model still continues, which we don't know if it does, because the model was created with the data between 2003 and 2009. Okay, so what are we asked to do?
Substitute x for whatever it is for the year. So x in number 1 is 4,
Good?
and x in number 2 is 12.
Excellent.
And then you just substitute it in the first equation.
That's it. So I will say f of x is 8.6 times 1.03 to the x. So f of 4 will be 8.6 multiplied by 1.03 to the 4th power. And of course, f of 12 will be 8.6 times 1.03 to the power 12. Let's punch them in.
So for problems like these, you just do it on the calculator.
We can't do it otherwise. Yeah. I will not be able to, I mean, I should say, yeah, I could raise 1.03 to the 4th power, but it will take a
We
while.
don't have that much time.
Yes, I guess so. 8.6 multiplied by 1.03 to the 4th power. And press enter. And I got 9.68 roughly. What does this mean? 9.68 what? Billion pounds. Very good. And the same thing, I will just recall the previous entry.
So do you write f of 4 equals 9.6 billion pounds?
Say it again.
When you're writing the answer, do you write?
Yeah, I'll show you in a moment. Let me just, yes. Let me just override this by 12 and press enter. 12.26. Okay, so this is what I recommend. f of 4 because I specified here what f of x means. So then f of 4 is approximately this, f of 12 is approximately that. Very good. Back to section 12.2. Problem 38. On page 728. F of x equals 7 divided by 2x plus 4. I'm asked to find f inverse. And I am told this function is 1-to-1. Don't worry about it. It is 1-to-1. It has an f inverse. Just find f inverse. Can anyone tell us what to do? What is the first step? Anything, anything. Excellent. So y equals 7 divided by 2x plus 4. This is the first step. Good. Wonderful. Why am I allowed to do that one more time?
Because f of x basically is x.
Right.
Like it changes with when you change x.
Excellent. Couldn't say it better. Now what?
Solve
4.
y.
Exactly. That becomes f inverse. How do I solve this equation and what type is it? Because if I know what it is, then it's a blink. It has variable in the denominator. Okay, here's your hint. And I would like you from now on, please remember. Right. Right? If I have a fraction on the left and a fraction on the right, nothing else, and the equal symbol in between, I'm done. So 7 equals 2xy plus 4x. And I'm solving for y. Please remember proportions. That's why we studied them. So now this is linear. There is no fraction. There is no denominator with x or variables, right? If you see a fraction and you see variables in the denominator, you have to think of rational. If you have something like this with no denominators and there is no square root, no absolute value, then this is linear in x and in linear in y. So it's not exactly linear because it has two variables, but we are solving only for one variable. So what do I have to do? And divide by?
2x.
Right. So you have two options here. You have to be very careful. One option is to divide both sides by 2x term by term. So if I do that, so this is one option and this is the second option. If I do that, then I have 7 over 2x minus 4x over 2x, which is negative 2, and that is y. The other option is to just divide by 2x as one term. Both are correct. So f inverse is, let's say, this or this. It doesn't matter. I prefer this, but it's the same thing. What I don't want to see, and that will make me cry, is something like this. And this will make me cry. Why will this make me cry? Terms. Exactly. This x is a factor in the denominator, but this x is not a factor in the numerator. And that would be terrible to do. Okay. Good. One more. Let's look at problem 40. Same question. Page 728. And 40 is f of x equals x minus 5 raised to the third power. We're asked the same question, which is find the inverse of this function. We are told the function is 1 to 1. Don't worry about it.